Hello again. We're going to do another practice round with atoms, determining the different subatomic particles, protons, electrons, and neutrons, how to write it in isotope notation, how to determine overall charge, and what name we would give that, and atomic number, given a full atomic symbol notation. So I'm going to do this one. I'll do this one a little slower with some pauses so you can check your answers. And then you'll complete the rest of the worksheet, 3 pages, I believe, on your own. If you're not one of my students, I do have a link to this PDF as a PDF document in the description below. Alright, first one. Again, isotope atomic symbol. You'll see overall charge in the upper right. You'll see mass number in the upper left, and atomic number in the lower left, and symbol in the middle. Isotope notation, again, I want you to use the long element names so you can get used to what these elements are based on their symbols, some of the most common ones. And F is for fluorine. So, fluorine, oop, I misspelled that. Fluorine. Dash, remember dash, not negative. This is not a negative mass. You can't have negative mass. I want the dash mass number. The isotope of fluorine we're dealing with here is fluorine 19. Fluorine with a mass number of 19. Alright, atomic number. So that's in the lower left-hand side. So atomic number 9. Atomic number tells us one of our 3 subatomic particles. Atomic number is defined as the number of protons that element has. So if it's fluorine, it will always be atomic number 9, which means it'll always be 9 protons. That defines your element. Overall charge can change, therefore changing the number of electrons. The mass number can change as the isotope varies, and that changes the number of neutrons. But fluorine will always have 9 protons. If it doesn't have 9, it's not fluorine. So, let's fill in the next piece. Overall charge. We have a negative sign up here. When you only see a negative sign and not a number, that means the magnitude of the charge is only 1. It is a 1 minus overall charge. So overall charge, 1 minus. If it is 2 or 3, they will actually show the numbers. And remember, if it's blank, there's nothing in that corner, then the overall charge is 0 and the atom is neutral. This atom has a negative sign. Neutral was for a 0 overall charge. Cation, again, you can see that positive sign written right in the word cation, or you can remember cats have paws. Paws are positive. So cations are positive ions, anions are negative ions. This is negative, whether it was 1 minus, 2 minus, 3 minus, or some other minus. Those are the most common. It is an anion. So this is where it gets tricky. Last video we looked at only neutrals, so number of electrons equaled the number of protons because they had to cancel each other out. In this case, I want it to be negative, but I can't vary my proton number. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 positive protons. 1, 2, 3, 4, 5, 6, 7, 8, 9. I need it to be negative by 1 charge, and every electron has a negative charge. So go to neutral. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's what it would be if it was neutral. They would all cancel each other out. Dun, 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 dun. But I need it to be negative. So I can't remove a positive proton. It won't be fluorine. So it means I need to add an additional electron, giving me 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons. The other way of doing this mathematically is that the overall charge equals protons minus electrons. So you know you have 9 protons minus how many electrons in order to get to a negative 1. Well, 9 minus 9 would equal 0. I need to go to negative 1. So 9 minus 10 would get me to -1. If you rearrange this, you can figure this out. I'm going to keep it simple here. Do it visually, or plug that in. 9 minus 9 would equal 0. 9 minus 10 equals -1. Last one, neutrons. Neutrons you can figure out based on the mass number. We know the mass number is 19 from either the symbol or the isotope notation. The mass number is the sum total of protons and neutrons. So protons plus neutrons equals mass number. So protons, 9, plus how many neutrons equals 19. 9 plus what equals 19. 9 plus 10 equals 19. Alright. And that gives us our fluorine atom as described here. Alright, for this next one, pause the video, see if you can mimic my work for fluorine on these. I'll speak through it. I'm not going to pause as long as I did in the last one. Pause after each one if you want to do them one by one, or pause before in order to solve the whole thing. There we go. Here's the solution. So isotope notation for O. O, most of you probably know, is oxygen. Oxygen dash mass number 16. Oxygen 16. Or written using the symbol, but remember I do want the long element as well. But you can give me symbol as well. It's O16. Atomic number is located in the lower left. Mass number in the upper left. Overall charge in the upper right. So atomic number 8 gives you which of your 3 subatomic particles? Protons. Mass number 8, protons are 8. Overall charge. This time nothing is being hidden, so we don't have to make any assumptions. It is 2 minus. Magnitude of the charge, direction of the charge. Now again, neutral would have been if it was 0, anion if it's negative, cation if it's positive. This is negative, so it is an anion, a negatively charged ion. Alright. Electrons, based on overall charge, we know we have 8 positive protons. 8 minus what number of electrons would give us a -2? So 8 minus 8 would even us out at 0. I want to go more negative, so I need to go 8 minus 10 to get to -2. Let's prove that to ourselves visually. If we have 8 protons, 1, 2, 3, 4, 5, 6, 7, 8. Remember, don't be tempted to touch your proton number. You can't change it. It is the atomic number. It is bound to that number based on oxygen. The only thing you can vary to change the overall charge are electrons. Turns out they're very easy to... Oh, sorry. You can't see my work down there. It's very easy to remove or add electrons. Not so easy to remove or add protons. So, how many electrons? Let's prove it to ourselves. We thought it was 10. 1, 2, 3, 4, 5, 6, 7, 8 electrons would cancel, 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 cancel. But we need 2 negative charges, so we need 2 additionals. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. Neutrons. Neutrons are the number of protons plus the number of neutrons to give us the mass number of 16. So my math should be 8 protons plus how many neutrons equals 16. 8 plus 8 equals 16. So, yep, cool. All right, you go ahead and do the rest of this document. 3 pages. They get more complex at the end. See how well you do. Good luck.